All right, good afternoon, everyone. I understand that I am in the way of you and the bar, so I will try and be brief. Special thanks to our sponsors this year. Apparently I'm supposed to put this slide here and talk about all the wonderful people. I think James got all of them on there finally, so go check them out. A little bit about me. I'm Ryan Coates. Some of you may have seen me in previous years. I've talked at a few of these things. I'm an engineering leader at one of the big four, and my skills mainly focus on software, cloud, and infrastructure these days. You can find me on LinkedIn and Twitter here. Actually, I should probably fix that tweet link, but never mind. It probably won't work. We're going to talk today about how to make APIs that users love or want to use, per se. Anyone ever had to deal with an API they absolutely hated? Yeah, same. And they're still around. And it's not just legacy APIs. It's not like, oh, this one's SOAP, so of course it sucks. It's modern, pretend RESTful APIs that were written by 10 different teams who didn't have a conversation between them at all. And this is kind of what we will deal with. And for those of you who coming from that PowerShell world, you're used to consuming APIs, you're used to passing that stuff into objects, and then now all of a sudden you have 50 different objects because nobody really had a conversation. So what users really want when they talk about good APIs they enjoy using, they want consistency, they want understandable APIs, documented APIs, and they want APIs that are repeatable, APIs they can use again and again without concern. Anybody ever dealt with an API breaking change that you got no warning about? Yeah, only one of you? Okay. I know you have, Missy. So I want to start with the sacred vow. And those of you who've been around the community long enough have probably heard this. This is something that the PowerShell team kind of talked about when they first started PowerShell, and it's something Jeffrey's mentioned a few times. If you learn PowerShell, we will do everything we can to make that investment worthwhile. And I think the same can be said for good API suites. Anybody ever use the Azure APIs, AWS APIs, any of the big hyperscalers? There's a reason that regardless of how many hundreds or thousands of resources they have in their API suite, there is a look and feel to them. There are properties that are the same regardless of resource. There are formats of the property names that are the same regardless of resource. It means the investment you make in understanding how to consume their APIs pays dividends as they add in new features and make tweaks and stuff like that, right? So consistency, or consistent. How do we make APIs consistent? What are some of the things we talk about? And this is a quote. This is actually an old quote. This is from 1998. This book was come out. Architecture, the set of design decisions about any system that keeps its implementers and maintainers from exercising needless creativity. We've all been there. We've all like, okay, how can I play with the latest and greatest? How can I implement these new changes with zero interest in whether or not that messes up the customer experience, right? Things like architectural guardrails, architectural standards, and approval boards and stuff exist mainly to bug us, but also because they are tasked with thinking about these broader scopes, right? And a lot of the stuff we're going to talk about today is really not, if you're building a single API for this one side project of yours, it probably doesn't apply. But if you're working in organizations with teams of people, with multiple resources that people need to consume together, this kind of consistency becomes a bigger deal, right? If I was at home and I made 3 separate products, those products don't need to look the same. If I made one product with 3 or 5 or 15 different resources, those things should start to look the same, right? So let's just jump into a demo, and I'm going to assume this doesn't break my screen, because it's been doing that a lot. But all right, so let's go back all the way to API 1. All right, and this is my PowerShell Heroes API that I've been working on. This is version 0. Anything jump out at you guys when I call this? Can anyone tell what language this is written in just by looking at the API? No guesses? Oh. It could be PowerShell. This is actually written in C#, which is why you see the default behavior for the property names here. These are in Pascal case, which is generally what C# defaults to. You'll probably see this in other frameworks and languages of a similar base. If I move over to this other example here, refresh, you'll notice that the case of the property names has changed. This is what's called camel case. This is the default for Python. It's also considered one of the most accessible property naming formats. Okay, camel case is easy for humans to read. I don't know why that's the thing, but that is generally how people have come to pass, right? So that's a pretty easy change in PowerShell, not in PowerShell, in C#, right? If I go back to this V1 version here that I was working on. So you'll see here a default, I'll go back to that V0 one just to show you the differences. And again, this is not a PowerShell talk because most people don't build APIs in PowerShell. It's a bit tricky. There were a few frameworks years ago that tried. I don't think they went many places. Oh, I didn't check something in. This could be awkward. But
yeah, get demo.
There you go. All right, so this doesn't look like it's working anymore, but we'll see. So as you can see here, this is that V0 version, right? So you notice it's just default ASP.NET Core 8. It's a minimal API, so I don't have MVC or any of that fancy stuff in it. I'm just creating a web app, creating a hard-coded object, and spitting it out. Well, that's it, right? And that's why we get that default behavior in the form of our casing here for property names, right? So when we go to V1 here, I made a quick change just to, again, bring some standardization in. Let's say I've got some Python teams building APIs in Python. I've got some teams building stuff in C# or Go. Part of good APIs is about separating that presentation layer. And let's be fair, an API is the presentation piece of the puzzle. It doesn't need to be coupled to anything else. It can be its own completely separate thing. If you've got multiple teams working in multiple frameworks, multiple languages, multiple kind of legacy apps, it's very important to try and get that presentation correct because you're not likely to be going back to 40 different product teams and components and saying, I need you to all do the exact same thing, because they won't, right? But you do get some control if you can enforce presentation standards. So you'll notice here we've added a quick JSON serializer here to basically say, hey, this is a C# app, but we want our API responses to be snake case. Easy as that. And then I think we implement it somewhere down below, right? So here's the actual extension method that's used. So now I have a C# API that spits out this, and I have a Python API that spits out basically the same thing. So from a presentation perspective, those contracts are now the same. And this is an important thing when we talk about APIs. APIs are generally built as platforms for other people to build upon. I assume most of you guys have all used PowerShell to call APIs so that you can do other things with that data, right? Or manipulate things, right? You then have your own set of customers who rely on your work, even though you're relying on someone else's work, right? So, APIs themselves, it's a kind of interesting space. You all saw the slides this morning where they talked about a big list of things, and API gateways was one of the ones that she called out. The API gateway market alone by 2030 is supposed to be worth like $54 billion. And you notice that was like one line out of 20, right? APIs in general are increasing companies' ability to kind of generate revenue. I think the last stat I saw is a few years old, but companies with API landscapes that are for public consumption or paid consumption generally have about 12, 13% additional revenue year on year than companies who decided they weren't going to play in that space, right? And you've all seen this. Again, you've got a lot of APIs that we use for free. We've got APIs with software we buy, but there's also the API marketplaces out there that you pay to use. Anyone ever heard of Twilio? Yeah. So Twilio allows me to send SMS messages, emails, all kinds of things, and all I do is I pay per consumption. So, if I send 10 text messages, I pay a few pennies. If I send 10,000 text messages, probably pay a few hundred. But either way, I don't have to deal with that infrastructure, blah, 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 right? So let us go into the next demo. So this is kind of what we talk about property naming standardization, right? We want the same case. We want the same names, right? I could have had team one call this, just Twitter instead of Twitter handle, right? I could have had somebody use a different property name. But if you've got any kind of governance and control over the API landscape in your org, try and implement your standards here. Right? They're easier to win. You don't necessarily get in the developer's way. I'm not saying to the C# developers, you must store all the stuff in your database in snake case, because that's a style, that's a divergence in style guidelines for most C# apps, right? So you want to make the changes you can here in the presentation layer. Let us go to, I'm actually going to skip 2, jump straight to 3. All right. So This is version 3 of the API. This is now introducing a concept called a response envelope. And those of you who use messaging systems like PubSub or Kafka or anything like that, you'll be familiar with this kind of envelope concept. But it's also used in APIs as well, right? So imagine in this example here, which I cannot make, there's so much of this screen is just dead space. I'm trying to make it bigger for you guys. So there's a lot of transaction information when I make a request to an API that has absolutely nothing to do with the resource. Now, some folks will put a lot of this metadata on the resource itself. It's not where it belongs, right? Things like the transaction information, that is metadata for the request. It's nothing to do with the resources I got back, right? Type, there's some argument there. You could put type on the resource. Same with version. But again, these are things that you kind of want to decouple from the resource itself. So we could put them here in this envelope, and then we have a data object. Anyone who's ever done any front-end dev will be fairly familiar with that data pattern. A lot of responses you get back to the front end have a data array or object that you can then crawl to get all the things you actually cared about. This is similar to how we use invoke REST request in PowerShell. Like the .content block has the actual response, and if you just looked at the return, you'd get all the other HTTP metadata that you didn't really care about, right? I'm assuming you're all familiar with get REST method, or get, what's the other one? Invoke web request, yeah, that's one. So here we have two objects coming back here, and again, you've seen the pattern before here. Can anyone tell me, just from looking at this, whether I'm hitting a C# or a Python API? Can anyone tell me if I'm hitting a SQL database or a Mongo database? And that's the point, right? The fact is I spent a lot of time wiring all this up just so we could kind of go through these examples. There's about 8 different containers making all this demo as well, right? But the fact is, when abstracted properly and cleanly, you as a user don't know whether that is running in this database or this language or this language. And that abstraction is important because it allows you to refactor those applications as you go through, without running into any troubles, without breaking that contract with the user. Right? And that's the big pain point most of us have. It's like, oh, somebody broke my API. I've been using it for 3 years, and they didn't tell me about it. Right? They added a new field that they made mandatory. They changed the look and feel of something. They didn't tell anybody. Right? So that's where consistency comes in. Let's jump back to the slides quickly. We'll touch on more of that in a minute. Ooh, sorry. So I want to talk a little bit about REST. There are other API protocols, standards, architectural styles out there, things like GraphQL, gRPC, things like that. RESTful APIs have come around, I think it was Roy Fielding's dissertation in like 2001 or something. I could be getting the year wrong. He wrote his dissertation on the architecture of network software systems, and he introduced this concept of REST, okay? Who's familiar with the term? Anybody know what it actually means? No? Represent something state transfer. I can't say words. But it basically means using the protocol itself, HTTP in the most cases, to inform a lot of the decision making of the API. And that comes down to things that helps us with things like discoverability and things like that. We know that if we send a GET to this endpoint, I'm likely to get something in response. If I was to change that GET to a POST, would you assume you would get something back, or would you assume you were sending something? Right. So this here is a URL, and the reason it's in different colors is just to kind of highlight a few things. When we talk about API resources, we talk about URIs a lot, Uniform Resource Identifiers. And for those of you anyone use Azure here? You see the ID field in Azure is just a long line of / and GUIDs, right? That is a Uniform Resource Identifier. It's not a full URL. You could slap that behind azure.com. You could slap that behind, maybe azurestack.com. I don't know, whatever. But the indicator part is not the full URL. It doesn't show you where that resource is located like a URL does. The URL also kind of infers things like the schemes, the protocols, all that kind of jazz. But we'll come back to this later when we start talking about versioning, because this is a passion of mine. But the idea is, URIs on the internet, the goal is that they point to unique resources, okay? Anybody used APIs with v1, v2 in the URL? Yeah? So again, we'll touch on that later. But yeah, that's not ideal because you now have 2 paths to the exact same resource. But you've told me there are now 2 unique resource identifiers for that resource. right? Remember, our API endpoint is really just showing you a representation of a resource. Now, if I ask for version 1 of the API response or version 2 of the API response, I'm asking for visualizations of that same resource. Like this one has 4 properties, this one has 6 properties. The resource I'm asking for is the same resource. So I really shouldn't change that URI piece of the program, right? And again, that comes back down to that kind of, consistency thing. We'll talk about the rest a little more. RFC 7807. Anybody really annoyed when they get 400 different error formats from an API? Does anybody have that experience? Because I do at work all the time. Error, a lot of people love defaults, right? Especially those of us who maybe came from an ops background, picked up PowerShell, maybe picked up a little basic Python along the way, and now somehow our boss is asking us to write all kinds of APIs, right? So we do all this and we're like, yeah, we'll just use the defaults. Well, here's the thing. Python and Flask have defaults. Python and Fast API have defaults. React has defaults. Vue has defaults. ASP.NET Core has defaults. If you rely on all these defaults, you're going to start giving your customers back a million different formats because you're just relying on defaults. This is an industry standard. Well, it's not. This is a proposed RFC, if I recall correctly. 7807 problem messages for HTTP APIs. And it basically defines a format that errors should come back into the user, right? There are a few mandatory fields here. There are a bunch of optional fields. You can extend it by adding new fields. Again, there's a whole RFC on it. But again, it kind of means that as a consumer, I can assume that I'm going to get one type back, a type of RFC 7807 for an error message, regardless of where it comes from the system. That makes it very easy for me as a consumer to build around that API and consume it, because whether you built your piece in Go, you built your piece in Python, and you built your piece in C#, if you've all wrapped up, if you've all kind of abstracted that error message into the same type, then I only have to kind of consume one type and I'm good. And the reason we're talking about this a lot, and specifically about REST, is because protocols like gRPC and GraphQL and things like that, they assume a bit more of a tighter relation between the client and server, right? So if you were consuming an SDK that Microsoft put out, you wouldn't necessarily need to worry what their API looked like, because they're owning the front end and the back end, and you're just consuming that SDK. With REST APIs, HTTP APIs, we generally build those clients. Like we're the ones calling, the object, getting it, manipulating it, do what we need to, right? We're not necessarily relying on a third-party kind of client for us to consume, right? gRPC uses proto-buffers, which means there's a lot of coupling between the front end and the back end, which is why they can have that performance benefit and that binary encoding, which is super useful if performance is your thing. But it also means you are kind of at the mercy of the producer of the client for, change management and things like that. All right, so consistent, standard property names. We did kind of talked about that. Standard property formats, talked about that. Response envelope, again, there's not really a standard for what a response envelope looks like. Like, your mileage may vary. And again, they don't need to be super complicated. If I go back to the example here, you'll notice we didn't really kind of go down to the bottom or not. We have a data array, which includes our return data. Oh, hold on, I got to press escape or you're not going to see the screen. My bad. Right, so we have our data array here, which has our actual objects that we asked for, right? We also have an errors array and a messages array. So imagine if this was a paginated response. I asked for 2,000 objects and it was giving me 200 at a time, right? I might have the messages in here like total count 2,000. So I know how many times I need to paginate forward. These links here, and we'll talk about this. This is kind of a concept called hate OAS, which we'll get into in a minute. Hypermedia. Let me get this right. Hypermedia as the engine of application state. Hate OAS, right? And this is kind of a core principle of REST. And it's about, has anybody ever used EC2 or Azure, and you've got like every time you look at the VM, there's a shutdown button and a start button and a reboot button. You notice how sometimes those buttons are grayed out. If the machine is running, you can't start it. If the machine is stopped, you can't stop it or reboot it. This is kind of how these links kind of work. When we respond with an object, if that object is in a certain state, we give you kind of things you can do with that object. But I'm not going to give you things you can't do to that object in its current state, right? This, again, is part of that kind of discoverability around APIs. If the API response just tells me all the things I can do to that object, that's great. I can just copy that and go do the needful, right? In this case, we're just populating this with the self, but obviously, we could have the next page, go to item 201 to 400 or whatever, go to item 401 to 600, and then the previous if that was a certain part of the pagination, right? Again, you'll notice this is in the envelope because these are related to the request, not to the object themselves. I might have links on the object that's like, hey, DM, right? And I can just click a button and it'll automatically open a DM to Justin or to Mike, right? And again, those are the kind of things, we'll get into that in a bit more with the Hate OAS. It's more of a Wikipedia read, not much to demo. It's a concept more than anything, right? Let's see if I wig the monitor out again. All right, so we talked about consistent errors. We didn't really talk about this. Avoid abbreviations in property names. I know a lot of you probably used to terms like VM, which is probably one that I'd let you get away with. But be mindful, whilst API responses are really designed for computer-to-computer communication, a lot of times humans have to look at those responses, and a lot of times when they do, it's in a high-stress environment, like something broke. We also deal with team members from all over the world, potentially, blah, blah, blah. Abbreviations often bring with them certain cultural connotations, certain kind of regional kind of, dialect, whatever. Be mindful. If you're going to use some industry standard term like VM, you probably get away with it. But if you're going to use some weird internal kind of thing that maybe makes sense in, Seattle, but doesn't make sense in, Georgia, don't do it. Use the full word, spell it out a little clearly. It's much more accessible then for the users. It's much more, and again, from a computer perspective, it doesn't matter. You're going to add like half a K of kind of transfer, right? And again, REST architecture standards. We didn't jump too much into it because this is not a REST talk. But again, things like HTTP verbs. So we use those to define the types of default methods we're doing on resources. There are formats that both the Microsoft Style Guide and Google API Style Guide put out for how to handle custom methods, right? For instance, rebooting a VM. Well, do you do a put? Do you do a post? What do you delete an object called VM is running? I don't know. No, generally you would have a custom method for that. And again, depending on the style guide you've picked up, depends on what that might look like, but it's about consistency. Make sure if this resource uses that format, make sure the other resources use that format, right? And standardize that as an org. Understandable. API should be understandable. Again, a lot of good API stacks these days. We talked again about API gateways and things like that. A lot of these will do things like create documentation for you on the fly. API specifications are generally pretty self-documenting. Let's just jump into this one. I have too many demos here, but we internally try and encourage what we call spec-first API design. And this is kind of counter to the code-first API design that many of us are probably used to. Hey, I need you to solve this problem. Okay. And you just start writing, right? And the thing is, very little thought goes into that. And you sit there and you debug and you get, okay, it's working. Cool, but how much time did you spend getting it to work, right? Do you care what the user experience is, right? Do you care what the errors look like, or did you just ignore them because you were fine? Spec first means we design the look and feel of that user contract up front, and then we hand that off to developers and says, make it look like that, right? So if that C# example we had in version 0, where I had Pascal case, if my API spec gave a response body that had snake case in it, well, when I give it to my dev, well, they're going to know they're not meeting the spec if they just spit back Pascal case, right? The other important thing about doing spec first is we use that as the basis for things like contract tests. Let's say you go and change, is anybody familiar with Swagger? They've heard of Swagger? Yeah. So Swagger kind of got renamed a while ago. Swagger kind of stopped at version 2. It got kind of introduced as Open API in version 3. It is a kind of domain-specific language, so to speak, for defining APIs and what they look like, right? So it's I don't have a live demo for this. I'm just going to go to a website. Do I have it open? There we go. So this is Redoc. Redoc is like Swagger, and it takes your OAS file and generates a pretty documentation site for you, right? So this one, for instance, has a couple of things here, right? You can get museum hours by sending something. You can create events, get events, delete events, assuming you have permissions, all that kind of thing. And then we have like buy tickets. I can buy tickets, right? And all of this is generated from the spec. And I wonder if it's actually going to let us look at the spec. Usually it does. But I don't see a button for it. That's a shame. Maybe it's on the front page. Ah, well, never mind. But this is basically generated from a YAML or JSON file, and I'll show you a quick example over in Postman here. So this is, obviously, my API here is very boring. It does, in fact, not have a ton of stuff to do. So this is kind of the API spec in YAML format. So this is an OpenAPI 3.0 file. This is the name of the API. Apparently, I didn't version it properly. This is the paths to it. These are the operations. These are the expected responses. And again, this is very simple. Well, we only have kind of a 200 get response. It's not like I've wired up the full CRUD. Here's our object, right? We've got both our, servers defined. Again, this is kind of just local stuff. But if I was to take this and run a contract test against this, right now, my objects would fail because I've introduced that response envelope. I'm running on a different server address, all these kind of things. So this would say, yeah, you mostly worked, but this doesn't check. I can't call that, right? So with an API spec, I can generate a Postman test like this, or I can also run it in the what's called Newman, which is, what do I do? Newman run. All right. So this, you can see here, it tested it tried to hit this endpoint. It got a status of 200. It was wrapped in the envelope, and the hero data structure was correct. And if I show you what that looks like over here, and I will zoom in for you guys. Oh man, I hate how it does that sometimes. Come on, go full screen. There we go. All right, so this is what a Postman test looks like, right? So it's telling me, I'm expecting a property called this. I'm expecting a property called this. I'm expecting if I was to change, if I then returned back Pascal case, this test would fail, right? One of the things I like to do is go into this test and change the server address, which is here. Right, we're going to save that. We're going to then rerun it. Now, both of those tests passed, and yet in one of those examples, I'm hitting a Python API, running fast API, and in one of those examples, I'm hitting a C# ASP.NET Core API. The fact is, I didn't change the test. I just changed the endpoint I was pointing the test at. That means I can guarantee that the contract that both of those are serving is the same, right? And again, that's really important when you come to start refactoring stuff or when you're looking for to catch breaking changes. A lot of times, we really don't mean to introduce breaking changes. There are tools like Swashbuckle built into C# that output this kind of OpenAPI file on the back end, right? So if I fat finger a class name, it won't error out. It's just going to give me a new Swagger file. And you can't really use that for contract testing because if it's just going to be tightly coupled to every typo you put in your code, it's not really useful for the user, right? I've got a few teams that still think that's the way to go. They just upload the new one anytime there's a change. I was like, dude, you can't change the API, right? It's not the move. So here we just have that example of both of those working, without any changes other than the port, right? So again, that gives us confidence that, yeah, we've re-implemented this API. Everything seems to be working. I'm not likely to get too many complaints from users. But we'll get back to that in a second. All right. Find my thing here. And then we've got repeatable. Ideally, we want API calls that we made yesterday to give us the same results tomorrow, right? So the first thing about generally REST APIs is we want them to be stateless. Stateless basically means that I shouldn't have to I shouldn't rely on any information the server has kept from my previous requests in order to do something next time, right? Also means if I send the same request tomorrow, I should either get the exact same results or you should tell me that object already exists. Now, for those of you who've done a lot of creations or posts with APIs, you kind of know what I'm talking about. Sometimes that'll just create 3 more objects if you send 4 API requests. Other times it'll say that object already exists. A lot of times we use dynamic IDs. So if I ask for a VM, then ask for another one, it's like, okay, I'll give you another one. If you ask for it with the same restricted property, like maybe the same name, I think Azure uses names as a reserved concept. If you ask for a VM called test1 and then you ask for a second one, it'll probably just come back and say, sorry, test1 already exists, right? Which is good because you haven't now created a second VM for no good reason, right? When you didn't mean to. But again, that's not that's not necessarily what people want, depending on what the API is doing, right? I think VMs is a good example where you maybe don't want to fire up 4 just by accident. They cost money. Whereas, maybe grabbing an email address or some get commands. Get commands should always be cacheable. They should always be kind of return the exact same thing. You don't necessarily want to get different results with the same get command unless the data has ultimately changed, right? And again, when you're doing things like caching and things like that, there's a concept called e-tags that you can actually use in caches to say this resource has not changed. And e-tag is basically like it's not quite a hash, but consider it like a hash for the resource itself. If the resource hasn't changed, the hash will be the same, so you'll get a cache hit and you'll get a response from a cache. If the e-tag has changed, you'll get a cache miss and you'll have to go all the way back to the database and get the other, the fresh results, right? So what else we talk about repeatable? Get my new slide. We'll come back to that one. Right? Should be stateless. API should also be versioned. Now, this is an interesting thing. We'll get back to my versions and URLs as part of this, but APIs, especially when you're creating a platform with APIs, right? You can't just say, I bumped it to version 2 because there's a breaking change and I overwrote version 1, right? You still potentially have consumers on version 1. Right? And you'll see this in Azure and AWS and stuff. When they release a new version of the API, there's a plan for the old version. There's a sunsetting period. There's a, what's the word? It'll come to me in a minute when I don't need it. But there's, there you go. Someone will know. There's a deprecation. There's a life cycle process that says, maybe we support 3 previous versions. And so when I release a new version, the third version now drops into, its sunset window and it'll be gone in 6 months, right? For some products, that's, and again, this is very much a business decision, right? If I know that I still have 1,000 users on version 1, even if I've got 20, 30,000 users on vCurrent, it doesn't mean I want to get rid of the first one if I've still got 10,000 users. I've got to find a way to encourage them to get off of it. And a lot of that's through things like new features. Yeah, we don't add new features to version 1 anymore. We don't add security fixes to version 1 anymore. I'd say be careful with that kind of claim because you're still on the hook for it, right? But you've got to kind of have that business strategy of how do I get those 10,000 users off of version 1 and move them onto version 3 or 4, whatever your life cycle period is. But you want to be mindful about it. You want to document it. You don't want to say, version 3 came out, we're turning version 1 off in a week. A week? I plan my work quarterly. What do you mean a week? I don't have time to figure that out. And again, this is like I said, a bit more of a business decision. The people that own these APIs should understand their user base, should understand what version they're on. They should be kind of helping them from a success perspective move off of them if it's becoming mandatory. You saw today in the demo, hey, you run a PowerShell command and it's something that's going to be changed or deprecated, you get a big yellow warning about it. Why? Because we don't want you to still be using it by accident and say, oh, well, you never told me about it. Going back to our response envelope, that messages kind of array, that's a great place to put things like that. You don't really want to break the API request just to warn them about something, right? But you can put that in the messages array and assuming they're reading it or assuming they're parsing it or the SDK is parsing it, they can do something with it. They can get that warning or that bubble or whatever that tells them, whoopsie, something's about to change. We'll go back to Hiram's law here. With sufficient number of users of an API, it does not matter what you promise in the contract, all observable behaviors of your system will be depended on by somebody. And I'm sure you've all run into this. I use an example of hey, my API takes 3 seconds to get you a response. And we decided that wasn't acceptable. We're like, no, that's too slow. We're going to rewrite it in Go. It's going to be super fast. In-memory database. Now it returns half a second. Except for those users that really relied on that 3 seconds to do a bunch of other work before coming back. And now they've got themselves in a weird race condition. That's not ideal, but eventually if you have that many users, they will all find something stupid to do with your API and depend on, right? So even though you've got a written contract, that written contract doesn't say, this will take 3 seconds to reply, right? It just says, this is what you'll get when I reply, right? So again, be mindful of things like that. Let's see if we can throw up another demo. I will actually take you to the code here. And I'm cheating a little bit because I'm not using the same database for the Python and the C#.
Press escape.
That is a good point. Let me put the passwords in first and then I'll press escape. All right. There we go. Ooh, why aren't you connecting? Maybe I didn't put the password in. Well, we'll come back to you. Here is our SQL database. And so this is the one that the Python ones are. Yep, so we just got our SQL database here. Again, Postgres, nothing fancy. And then if Mongo was working, I'd show you the Mongo equivalent, but is there like a cancel button? What are you doing? Ah, well, something had to go wrong in a demo. Let's try again. Ah, okay. There we go. And here's our collection here. Where, I kind of hard-coded the GUIDs here just so the demo kind of worked properly. But my point is, if you were to be migrating from one database technology to another, which is a fairly common thing when you start hitting scale limits or architectural limits, you don't have to break anything with the user. Anybody know when the S3 API last had a breaking change? Anybody consume that one regularly? 2006. The S3 API has not had a breaking change since 2006. Was it really? I thought it was like 2003 or something. It's good to know. So, and this is the thing, like obviously AWS and Microsoft, they have lots of very good software people on staff. They can do a lot of this planning and not shooting themselves in the foot. Most of us don't have that luxury. We have team members that kind of evolve organically. We have people that leave and come, and we don't necessarily have especially in smaller orgs, we don't necessarily have the governance and controls around making these things safe and making these things well planned out. To have an API that has evolved and improved so much, like S3 has 4 million new features from what it had in 2006, right? But for them to not have introduced a breaking change to their API is pretty incredible. But, again, I think you guys have probably all run into the experience where people do kind of, put their foot in it and, tweak things and break things and do whatever. And then you're like, oh, my users are calling up and complaining about bad user experience, right? Ultimately, that's what it all comes down to. Like our users, these are our customers. If we're building APIs, it's for other people to consume. Or other people's customers to consume, more importantly, and we have to be mindful of that, right? It's not about, well, this was the quick and easy way to build it. Put a little bit of thought into it, have a little think about how you kind of deal with this kind of change over time, which is the really important thing. Change over time is inevitable, right? You are going to get new language features. You are going to get new recommended practices. You are going to get new kind of ideas and styles. Being able to handle that in a graceful way and keep your users happy as you go through those turbulent times without screwing over them and their customers is fairly critical, right? And again, I know most of us don't build APIs ourselves in PowerShell, but I'm sure some of you have, Python, C# skills as well, or you wouldn't be here. But yeah, basically, I think that's the gist of it. Any questions? There's a lot of moving parts here, right? So when we go through the feedback stuff, I'll ask you about whether or not I should have made this a 90-minute one and just delve into stuff in more depth, because we kind of touched kind of high level on a few things, because we can go in the weeds real quickly on things like 7807 or response envelopes, or how to actually implement that in Python and C# without shooting yourself in the foot, right? But I figured if we're a bunch of PowerShell people, maybe we didn't want that much depth. If you actually go to this URL, there will be a gist with a bunch of extra links and information for you. But yeah, questions?
Yeah, you said API should be versioned, but you said don't use it in the URI. Can you expound on what?
Yeah. Well, and I will say this, there's definitely some opinion coming in here from me, and partly because I'm a bit of a purist, right? Like I said before, a URN or URI indicates a unique instance of a resource, right? If I version my API, let's say I have one S3 bucket, right? It's got my files in it. And today's version of that API response has 10 fields. And tomorrow's version of that API response has 14 fields because we made the bucket have more stickers on it, right? That is still the same bucket with my 10 files in it. Should I now have 2 ways to get to it, right? These are really representations of the bucket. They're not the bucket, right? So the URI should stay the same, and I should just say, hey, give me the view. It's like if you go to Facebook on the web versus on your mobile. I mean, it's still your account, it's still your pictures, it's still your contacts, but you have a completely different experience on your phone versus your desktop, right? These are views into the same thing, right? And so you can do things like version requests through headers, through accept types, right? Instead of saying like, you can say, hey, accept version, PowerShell Hero v1 versus PowerShell 2 Hero v2. And again, these are where certain developers start to get a little ruffled because that's extra work for them. That's not one of the defaults, right? I'm sure we've all seen the Abel Wang t-shirts. Don't accept the defaults, right? It takes a little bit of extra work, and this is where it kind of becomes interesting because it's not necessarily the best user experience when you start hiding stuff in headers, right? And again, some users might swear by, no, just give me the version 1, version 2, because they don't necessarily care about the semantics of the web or how it was architected, right? If I know I'm just asking for v3, I'm just going to put v3 in the path, right? I think I had another example of that. So I can. And this is where things like API gateways and proxies really come into play. So you'll notice here, rather than just going to a port, right, I can actually go to the name of the resource, PowerShell Heroes, right, and I get the same response. But I could easily change that if I go here and hit my proxy configuration. What if I wanted to go to v3? That might work. Or I might break everything. Okay, you're not supposed to work anymore. Yeah, you're not helping. Why are you both working? I don't get it. Do I have something else in my Docker Compose file that I didn't know about? Oh, yeah, I guess I do. Okay. I was trying to get them to load balance because I thought that I didn't have time to finish the traffic demo, and it's not a traffic talk. But you can actually, obviously, through API gateways and load balance and stuff, actually, I could have had that Python and C# one running, and I would have just been randomly hitting either one, and again, you as a user wouldn't notice or care, right? That's again, it's not something that's super common. If I want multi instances of my app, they're probably all the same app, just running in 10 places. I probably don't have a Python app and a Go app and a C# app, but this was a demo, so you do the fun stuff. Let's go back, fire that up again. There we go, that's better. So now if I go to V2, should work, yeah. So V2 and V3 now both work, and that's just my proxy is doing that, right? So if I go, well, I think I've got the proxy open somewhere, right? Yeah, come back, wrong button. So if you look here, we've got our two here, V2 and V3. We've got some middleware that kind of handles all the naming conventions and stuff. And so I can kind of change the path of that however I want. RESTful standards do tend to talk about like this kind of resource model in the paths, right? So again, you've probably seen this in things like Azure. You'll go to tenant /tenant ID /subscriptions /subscription ID. And this is how you gradually get down to the sub resources, right? And things like that. And that gives you a good idea of, hey, I know exactly where I am and how that hierarchy of resources works because it's in the URL, right? That can get a little bit annoying when you start having the vastness of the Azure kind of suite. I don't know if you've seen the URLs, like, right? I was like, why is there 10 resources under 10 other resources? But there's pros and cons to it, right? You've got to be mindful of how you structure your resources. Should this be a sub-resource or should this be a peer resource that just has an attachment point, right? It doesn't necessarily need to be a sub-resource. What if I could move it around? What if I could detach this subnet from this VNet and attach it to another VNet? Should it be a sub-resource of a VNet or should it be its own resource that has an attachment point, right? So again, these are kind of a bit more nuanced API design type considerations as you kind of work through your own kind of projects. But yeah, so V3, I wouldn't put it in the URL. There's other ways to do it. You can do it in, again, you can do it in things like headers. You can do it in, accept headers, version headers, X version header. I mean, there's a lot of places you can feed it in. Your API gateway could handle it itself as well. Like, if you go to just / we're going to automatically send you to the latest, similar to how people who are lazy download packages with no versions attached to them, right? But yeah, I mean, that's a very purist thing. And again, I would say a lot of folks don't necessarily agree with that. Do what works for you and your team and your org. You don't need to be a purist just because I am. Anyone else? Questions? I'm up 15 minutes early. I assumed Q&A. No questions? You're bored? You want to go to the pub early or something?
This ends at 5.
Not early.
Oh.
Right on time.
Sweet. We're going to crop that one out of the YouTube video, right? Well, in that case, thank you all. Like I said, you can go to this. I've got a little gist I put together with a few links to some of the things we talked about. Again, some of the things we talked about are probably best just consuming the Wikipedia article. There's a few blogs I put up there. And also reference my 2021 Automation Summit talk, which went into API documentation and stuff in a lot more detail. Feel free to watch it or don't. It's probably very embarrassing. It was a remote conference. And then, yeah, thank you. Please feel free to leave feedback. Again, if you think you'd prefer a more hands-on style one of these that runs a little longer, if it was completely boring and pointless, you have no idea why you came, that feedback's good too. Again, my name is Jason Helmig. But yeah, no, thanks for listening. And hopefully you guys will be able to build some awesome APIs that your customers will enjoy.